Questions 11 through 20 on the 2009 grade 12 AMC 12B. On Monday, Millie puts a quart of seeds, 25% of which are millet, into a bird feeder. On each successive day, she adds another quart of the same mix of seeds without removing any seeds that are left. Each day, the birds eat only 25% of the millet in the feeder, but they eat all of the other seeds. On which day, just after Millie has placed the seeds, will the birds find that more than half the seeds in the feed are millet? So what I'll do is I'll let a quart of seeds be equal to 1,024. And I chose that number just because it divides evenly by 4 very well. So they're saying that 25% are millet. And I think millet refers to some sort of a grass. So that means 256 are millet. And then the other remaining 768 are going to be the regular seeds. So here we go. We're starting on a Monday, right? And then we're having to figure out which day does the millet become more than half. So since the answer choices go up to Saturday, I'll just go up to Saturday. All right, so let's begin. So on the very beginning of this whole process, the amount of millet is going to be 256, and the amount of regular seeds is 768, right? So every time the birds eat them, they only eat 25% of the millet. So it'll go down to 192. And then they eat all of the regular, so it goes down to 0. And then you add a fresh new batch of 256 millet and 768, right? So this will equal 448, and this, of course, equals 768. And we just keep repeating this process. So on Wednesday, the 25% of that, so we're down to 336. And then they eat all of this, so we're down to 0. And then again, we add a fresh new batch, a quart, I should say, of 256 and 768. And this number then goes up to 592. And this is, of course, 768. Again, the birds only eat 25% of the millet, so this 592 goes down to 444. And this goes down to 0. We add a new quart, and that is going to be 256, bringing this total up to 700. And of course, we add 768 to this, and this becomes again 768. So now, are we more than half for millet? No, the millet is 700 and the regular is 768. We're not more than half yet. Maybe on Friday. So 700, a quarter, subtract that. So we get 525 and 0. And then we add 256 and 768. And let's see what these numbers are. This is 781. And this is 768. So there we go. We are now in a situation where the millet are more than half of the seeds in the feeder. And therefore that happened on the Friday. So number 11, the answer is D. The 5th and 8th terms of a geometric sequence of real numbers are 7 factorial and 8 factorial respectively. What is the first term? So A is the first term, and then the second term of a geometric sequence is A times R, where R is a common ratio. So they have 3rd, 4th, 5th, they're going all the way up to the 8th term. So this is our AR squared, AR 3rd, AR to the 4th, AR to the 5th, AR to the 6th, and finally AR to the 7th. So we are told that the 5th term is 7 factorial and the 8th term is 8 factorial. So we can take those two terms, AR to the 7th, and divide them, so AR to the 4th, and that'll be 8 factorial divided by 7 factorial. So this becomes R to the power of 3 is equal to 8, and therefore R is equal to 2. So now we have to figure out what is A. They want you to figure out the first term. So we can just substitute the value of r into that. AR to the fourth is 7 factorial, and r is equal to 2. So that is my equation. So therefore a is equal to 7 factorial over 2 to the power 4. 7 factorial is 5040. 2 to the power of 4 is 16. And when you divide those two numbers, you get 315. So the first term, which is equal to a, is 315, and therefore number 12, the answer is E. Triangle ABC has AB equal to 13 and AC equal to 15. The altitude to BC has a length of 12. What is the sum of the two possible values of BC? So our triangle obviously has two shapes. The first shape is something like this, right? Approximately. And the other one is where it's something like this, approximately. And we have to figure out both of those and then add them. So the first one, I'll label it A, B, C, and AB, they tell me, is 13, and AC is 15. And the second one, I'll label in the same way, A, B, C. And again, this is 13 and this is 15. Now, they mentioned the altitude, so I've got to draw those. So the first one is straight down from A, like that. And the second one is A down to that base right there. And they tell us in the question that the base, or the altitude, I should say, is equal to 12. So both of these will allow us to figure out two possible values for BC. The first value is going to be that length, and the second value will be that length. So here we go. So for the first one, let's see here. We can easily figure this out. We can call this x and we can call this y. So x squared plus 12 squared is going to be equal to 13 squared. So therefore x squared is 169 minus 144, which is 25. So x is equal to 5. So this is 5. And then very similarly, we do the same thing for y. 12 squared plus y squared is equal to 15 squared. And 225 minus 144 is my y squared, and therefore y will be equal to 80. Y squared will be 81, so y will be 9. So that's 9. So our first value for BC is 5 plus 9, which is 14. And now, in a similar way, we'll find another value for BC. On this triangle over here, let's see here, we'll call, again, it doesn't really matter, x and y. So 12 squared plus x squared is equal to 13 squared. So that means x squared is equal to 169 minus 144. So that means x is equal to 25 square root, which is 5. So this is 5. And now I can use the big triangle, this whole one, to figure out this x plus y. So 12 squared plus x plus y squared is equal to 15 squared. So that means 225 minus 144 is equal to x plus y squared. So that means that's 81, which means that 9 is equal to x plus y. And x is 5, so that means that y is equal to 4. So y is 4. So for here, this one, BC, is 4. So they want me to add up those two possible values, these two guys, and if you do, it's obviously 14 plus 4, which is 18. So number 13, the answer is 18, which is choice D. 5 unit squares are arranged in the coordinate plane as shown, with the lower left corner at the origin. The slanted line extending from A0 to 3, divides the entire region into two regions of equal area. What is A? Well, 5 unit squares would have a total area of 5 times 1 times 1, which is 5. So when you chop it in half, that area over 2 will be equal to 5 over 2. So that means this shaded region that they've shaded in gray is 5 over 2. So 5 over 2 is equal to that shaded region, but it can also be written in a certain way, right? It's basically the triangle subtract this 1 unit square. So the triangle is 1/2 base times height, and then I subtract from that 1 unit square that has an area of 1. Now the base is from here to here, which is 3 minus a. And then the height is just 3. So there we go, that's our equation. Bring the 1 over, and this is going to be 7 over 2 is equal to 1/2 3 minus a times 3. And therefore that will be 7 times 9 minus 3a. And therefore 3a is equal to 2. And therefore a is equal to 2 over 3. So number 14, the answer is C. Assume 0 is less than r is less than 3. Below are 5 equations for x. Which equation has the largest solution x? Now if you look at the answer choices, they're all similar. They all are of the form something in the brackets to the power of x is equal to 7, and then you multiply that by 3. Every answer choice is like that. They just vary with regard to what's inside the brackets. So every answer choice can be written as follows. N to the x is 7 over 3. And if you take the log of both sides, you get log of nx is the log of 7 over 3. And then, of course, x comes out front. And then we have the log of 7 over 3. And then isolating for x, we just get the log of 7 over 3 over the log of n. That's it. So our task is to maximize x, right? They want the largest x. You get the largest x if we have the smallest value of n. So to maximize x, we minimize n. So we want n to be as small as possible. So let us list all the different n's that they have. They have 1 plus r, 1 plus r over 10, 1 plus 2r, 1 plus root r, and 1 plus 1 over r. Now our goal is to minimize. Now everything has a 1, so I can forget about the 1 and just look at the r's. R over 10, 2r, root r, and 1 over r. Okay. I want to minimize this guy. Well, some of you can immediately figure it out, but if you can't, just substitute a number. So I'll substitute any of these. R is between 0 and 3, so let me substitute 3. Well, actually, no, it's between 0 and 3, so I can't put 3. So let me put 2. It doesn't really matter. So I'll put 2. If r is 2, this becomes 2. This is 2 over 10, which is 0.2. This is 4. This is root 2, which is approximately 1.4. And this is 1 over 2, which is 0.5. Right? And clearly, the smallest of these is this guy. So that will be the one I select, which will maximize x. And that is choice B for number 15. Trapezoid ABCD has AD parallel to BC. BD is equal to 1. DBA is 23 degrees. BDC is 46 degrees. The ratio of BC to AD is 9 over 5. What is CD? Let us, as always, draw a diagram and see what we can do, see how this helps us. So let's draw it in a way that those two are parallel. So something like this, I believe. And let's label this now. We've got A, D, B, and C. And any other piece of information they give us? I believe so. They tell me that BD is equal to 1, and then they give me some angles. So this is 1, and then the angle is DBA, which is 23, and then the other one is BDC, which is 46. Okay, so the approach to this question is actually not what most people think. It kind of screams cosine law, right? But you actually don't do that. What you do is you extend BA and CD. And when you extend them, they will meet at a certain point. I'll just call that E. And this helps us. So first and foremost, let's label some angles here. This angle we know is 46, right? So this angle, since all the angles about a line equal 180, this angle is going to be 180 minus 46. And that is 134. So this is 134, that angle. And therefore, this angle right here will be 180 minus 134 minus 23. And if you do that, that actually is 23. So that means, since these two angles are the same, that is an isosceles triangle. Doesn't look like it, but I know it's not drawn to scale, but that's okay. This is going to be the same as that in terms of its length. So since BD is 1, ED is 1. All right? Now at this point, there's similar triangles. ADE, that triangle, is similar to the full one, which is BCE, like that. So the ratio of the sides will be the same. So that means AD over BC will be the same as ED over EC. Okay? Now AD over BC, they tell us in the question, is 5 over 9. Well, they tell us the other way around, but I just flipped it. And then ED is what we are, no, ED is 1, and then EC is ED plus DC, right? So we can work with this. 5 over 9 is 1. ED is 1 plus DC. So this will allow us to figure out CD, or DC, same thing. Cross multiply, get 5 plus 5 CD is equal to 9, and therefore 5 CD is equal to 4, and therefore CD is equal to 4 over 5. So number 16, the answer is B. Each face of a cube is given a single narrow stripe painted from the center of one edge to the center of the opposite edge. The choice of the edge pairing is made at random and independently for each face. What is the probability that there is a continuous stripe encircling the cube? Let's first draw a cube and discuss this. And I'm going to label these faces. And I'm going to do it carefully so we don't get confused here. This one is 1, and I'll call that front, just so you know. This one I'll call 2, and I'll call that side. Side right. Well, don't really need to put right. Now this one I will call 3, and I'll put bottom so that you know. And then this one over here, 4, that's the side, left side. And then this one is 5, which of course is the top. And I'll put 6 here, which is the back face. All right? So hopefully labeling it like that will not cause any confusion. Now, the stripe has to go somewhere along the faces so that it's continuous, right? So this is one possibility, like this, right? Another possibility is like this, and the final possibility is like that. Okay? So in terms of our numbers, the first stripe is 5, then 1, then 3, then 6, right? Those are the labeled faces. The next possibility in terms of labeling is the 1, 2, 6, 4. And then the final one is 5, 2, 3, 4. So let me go through that again. Let me draw that again. So 5, 1, 3, 6. 5, 1, 3, 6 is the one that looks like this, where there's a continuous stripe like that. 1, 2, 6, 4 is 1, 2, 6, 4 is the stripe that looks like that. And then 5, 2, 3, 4. 5, 2, 3, 4 is the stripe that looks like that. Okay? So now we'll start talking about probabilities. When a stripe is painted, there's only two ways it can be painted on any face. It can be painted like this, or it can be painted like that. So in order to get the first scenario, we have to ensure that all of them, 5136, which is going to be like this, 5136, all of them match up. So that means for 5, there's only, of the two, one way we can paint it, right? We don't want it like that, we want it like this. Okay? So in a very similar way, for the 1, we don't want it like that, we want it like this. So of the two possible choices, we only choose one. So the probability is a half. And it's very similar for 3, we don't want this guy, we want this guy. So again, it's a half. And for the 6, same thing, we don't want at a cross like that, we want it up and down like this. So of the two, we choose 1, and that's a half. So we have to multiply this to get that full stripe, because all of those have to happen, and that is 1/16, right? And in a very similar way, I think you don't need me to talk you through the next two. They're identical. They're going to be also 1/16 and 1/16. And therefore, you add them all up, and that is 3/16. So number 17, the answer is B. Rachel and Robert run on a circular track. Rachel runs counterclockwise and completes a lap every 90 seconds. Robert runs clockwise and completes a lap every 80 seconds. Both start from the start line at the same time. At some random time between 10 and 11 minutes after they begin to run, a photographer standing inside the track takes a picture that shows 1/4 of the track centered on the starting line. What is the probability that both Rachel and Robert are in the picture? Well, I'll start off with some numbers. I'll let the track be equal to 720 meters. Right? It's always helpful to use a number. And we'll talk about Rachel and Robert, but they will be very similar in terms of their calculations. So here we go. So first and foremost, let's draw the track. And the photographer is basically going to cover about 1/4 of the track, right? So like this. For both, well, it's the exact same track. I'm just drawing it twice because I want to talk about each of them individually. So since I made it 720, 1/4 is 180. So this will be 90 if this is the start, S for start, and that's 90 on the other direction. And identical over here. So there we go, that's the labeling. And now let's begin. The formula we're going to use, of course, is speed is equal to distance over time. And the first thing, of course, is we want to figure out the speed. So for Rachel, her distance, 720, 1 lap of the track. She completes in 90 seconds, so her speed is 8 meters per second. For Robert, his speed is 720, but he completes a lap in 80 seconds, so it's 9 meters per second. Okay? So now we have to talk about, at the 10-minute mark, where are they? That's when this whole question begins. So we want to figure out their distance. So distance is speed times time. And for Rachel, her speed is 8, and the time is 10 minutes, but I have to convert that to seconds, so 10 times 60. And that is equal to 4,800. Now, 4,800, of course, I have to divide that by 720 to figure out where is she on the track. And if you do that, you get 6 with a remainder of 480. So that means she's gone around the track 6 times, but then she runs in this direction, right? Counterclockwise. So she's going to be 480, so approximately here. Okay, at the 10-minute mark. Now I have to figure out what time will she get here and what time will she be here. Okay, that is the key to the question. And if I can do that, then I'll be able to solve the question. So from here to here is how many meters? Well, it's 480. We're going to, not to the start line, but 90 before the start line. So that is 150 from here to here. So I have to figure out how long does it take her to travel 150. Okay, no problem. The time is going to be 150 and her speed is 8, and that is 18.75 seconds. So that means at 10:18.75 to be exact is when she reaches at that point. Now I have to figure out when she reaches this point. Well, I'm traveling another 180, so this time the distance is 150 plus 180, which is 330, and her speed is also 8, and this is 41.25. So at 10:41.25 is when she is there. All right, so now we have to do the exact same thing for Robert. We have to figure out where he is, what time does he reach here, and what time does he reach here. Okay, so first let's figure out where he is at 10 minutes. So at 10 minutes, it's going to be distance is speed over time. Distance is speed times time, actually. So his speed is 9, so it's 9 times 10 times 60, converting it to seconds, and that is 5,400. But we have to figure out where on the track is he. So 5,400 divided by 720, and that is 7 with a remainder of 360. So that basically means that he has gone around 7 times and he ends up exactly across from the start line like that, which is representing 360 meters from the start line. And now we have to figure out when does he get here, this point right here, and when does he get here. So from here to 90 is what? 360 minus 90, so it's 270. So from here to here is 270 meters. So we have to figure out the time. So time is 270 divided by 9, and that is 30. So he gets here at exactly 10:30. And now we have to travel another 180. So I've got to go 270 plus 180, which is 450, divided by 9, and that is 50. So that means he gets to here at 10:50. Now the question is, during what time interval are they both in the picture? Well, Robert doesn't get into the picture until 10:30, and he's in the picture until 10:50. But Rachel starts to run away from the end point of the picture at 10:41. So they're both in the picture between 10:30 and 10:41. All right? They're both in the picture between 10:30 and 10:41. So that is 11.25 seconds. And they want to know what fraction of that is between 10 and 11 minutes. So 10 and 11 minutes is 60 seconds. So that is our fraction. And if you put this in the proper numerical format without decimals, it's 3/16. So number 18, the answer is C. For each positive integer n, let f at n be equal to n to the power of 4 minus 360 n squared plus 400. What is the sum of all values of f at n that are prime numbers? Okay. So I guess we can make a table, n, f at n, and then see if it's prime or not. And hopefully this won't take too long. And let's see what we get. Okay, so for n is equal to 1, let's plug it in. F at n will be equal to 1 minus 360 plus 400, and that is 41. N is 41 prime? Yes, it is. So we got 1. When n is 2, we will get, let's see here, 16 minus 360 times 4 plus 400. And that's f at 2. And this is negative 1024. Oh, okay. That's no good. So it's getting negative. F at 3 is probably going to be negative also. So we get 81 minus 360 times n squared which is 9 plus 400, and that is minus 2759. Oh, okay, we're getting even more negative. So that's obviously not a good approach. So let's look a little bit closer at this equation. We have n to the power of 4 minus 360 n squared plus 400. Now, if I were to factor out an n squared, I get n squared minus 360 plus 400. So the only way that we're going to get positive numbers, other than the 1, which is an interesting exception, is if this is positive. If that's positive, then we'll get a positive. So that means that n squared minus 360 has got to be greater than 0. Yeah. So that means that n squared has to be greater than 360. So that means that n has to be greater than the square root of 360, which is approximately a little less than 19. So n's got to be greater than, I think it's 18.9, right? Because 361 is 19 squared. So there we go. So that means the only way we're going to get positive numbers if n is greater than 18.9. So let's try 19. Let's see what we get. So if n is 19, where's my formula? It's right here, right? But I don't want to use that one. I'll rather use this one. It's nice and factored. If n is 19, I have 19 squared times 19 squared minus 360 plus 400. And this is f at 19. And let's see here, 19 squared is 361. Yeah. And then 19 squared is 361 minus 360 plus 400. Okay, the math is good. So this 361 minus 360 is just 1, so this just becomes 361 plus 400, which is 761. And is 761 a prime? I believe it is. So I'll put a little check mark there. Now, so far I got 2, right? Because the question is, how long do I keep going here? 20, 21? Well, I looked at the answer choices, and I think I'm done, because 761 plus 41 is 802. And that's the largest answer. So obviously that's got to be right. So number 19, the answer is E. A convex polyhedron Q has vertices V1, V2 all the way to Vn and has 100 edges. The polyhedron is cut by planes P1, P2 all the way to Pn in such a way that the plane PK cuts only those edges that meet at vertex Vk. In addition, no two planes intersect inside or on Q. The cuts produce n pyramids and a new polyhedron R. How many edges does R have? So let's start with a little bit of a diagram using a very small polyhedron. And here's a little polyhedron that I want to discuss, just to kind of illustrate how this works. Now what they're doing is they're taking and they're chopping this. So let's label this first of all. Let's call this V1, V2, V3 over here, and V4. So they will chop it in these planes. So P1, for example, will cut only edges that meet at V1. So these are the edges that are meeting there. So it will only chop those. So P1 will chop it like this. So this is P1. P2 will chop edges that meet at V2. So it will cut there. And in a very similar way, P3 will cut the other one, which I cannot draw because it's on the other side, but P4 I can show you very quickly. It cuts like that, right? Now what I want to do is I just want to show you 2 cuts. So what I'm going to do is show you what this looks like after it's been cut by P4 and P2. So first I want to show you what it looks like when it's been cut by P4, just P4. It chops off the top. You see what happened there? And you see this is a very important shape. It became a shape that, well, in this one is a triangle. So that is the first thing I wanted to show you. Now I'm going to, well, attempt to show you what looks like when P2 has also been involved. And there you go. So that's very important to illustrate because it will give you an idea of what I will discuss next. So now we have to discuss this in terms of like edges and vertices and all that. They tell us in the question that Q has 100 edges. Now notice that each edge is cut by two planes. So for example, this edge right here was cut by two planes, right? It was cut by P4 and it was cut by P2. And once that happened, it made the shape look like this. And then when each edge is cut by two planes, it creates new vertices, right? Here's one new vertice, and here's another one. So that means that two vertices are created on each edge after they've been cut by the two planes. So now, once all these cuts are happening, this shape that is left over is no longer Q. They've given it a new name. They're calling it R. The original shape is called Q, but then the shape that has all the cuts is called R. So think about this. We had 100 edges to begin with. Each edge is cut by two planes. And then when that happens, each edge now has two new vertices. So that means in total, there are 100 times 2, which is 200 vertices that the shape R will have. This R right here. So, if that makes sense, let's move on to the edges. Now we have to talk about that because that is what they're asking us for. At any particular vertice, let's say this one right here, three edges meet. This edge, and that edge, right? You can see that. Similarly, for this vertice, three edges meet. This one, and that one. So since three edges meet at each vertex, and there's 200 vertices, the number of edges is 200 times 3, which is 600. But 600 is not one of the answer choices. Why? Well, because we've double counted. This edge, for example, we've counted for this vertice, but we've also going to count it for that vertice. So in this calculation, we have double counted. So in that 600 calculation, each edge was counted twice, so we have to divide by 2. So 600 divided by 2, which is 300, is the number of unique edges in our shape. And that shape, of course, was designated R. So 300 is the answer. And therefore, number 20, the answer is C.